Hey there, science fans. Today we're diving into the world of MEMS, Micro-Electro-Mechanical Systems. These are tiny machines, sometimes smaller than the width of a human hair. Don't let their size fool you, though. MEMS are doing some seriously big things. From the accelerometers in your phone that tell which way is up to the tiny microphones that let you talk to your voice assistant, MEMS are everywhere. They're in cars, medical devices, and even space probes. But how do we make something so small and intricate? Well, buckle up, because we're about to take a wild ride through the fascinating world of MEMS fabrication. We'll break down the process step by step, from the initial design all the way to the finished product. Get ready to have your mind blown by the amazing technology of MEMS. Just like any complex machine, building a MEMS device starts with a good plan. Engineers use specialized software to create detailed three-dimensional models of the device. They carefully consider things like the device's function, size constraints, and the materials it will be made from. Imagine designing a tiny gear that's only a few micrometers across. That's the level of detail involved in MEMS design. These designs are like blueprints guiding every step of the fabrication process. Once the design is finalized, it's converted into a format that specialized machines can understand. This is similar to how architects create blueprints that construction workers use to build a house. These digital blueprints are then used to create masks, which act like stencils for the next stages of fabrication. Get ready for the next step, where we'll explore the materials that make up these incredible miniature devices. MEMS can be made from a variety of materials, each with its own unique properties. Silicon, the same material used to make computer chips, is a popular choice due to its strength and electrical conductivity. Other materials, like polymers and metals, can also be used depending on the specific application. The chosen material is then deposited onto a substrate, typically a silicon wafer. Think of it like spreading a thin layer of batter onto a baking sheet. This deposition process can be done in several ways, such as sputtering, where atoms of the material are blasted onto the wafer, or chemical vapor deposition, where the material is deposited from a gas. The thickness of this layer is crucial, as it can affect the device's performance. It's like making sure your pancake batter is just the right consistency. Too thick and it won't cook evenly, too thin and it'll be too crispy. Now that we've got our base layer, let's move on to the really exciting part, shaping the material into the desired structures. This is where things get really interesting. With the material deposited, we need to carve out the intricate shapes that will define the MEMS device. This is done using a process called photolithography, which is like creating a microscopic photograph on the material. First, a light-sensitive material called a photoresist is applied to the wafer. Then a mask with the desired pattern is placed over the photoresist and exposed to ultraviolet light. The exposed areas of the photoresist harden, while the unexposed areas remain soft. Next, the wafer is washed in a developer solution, which removes the soft photoresist, leaving behind a patterned layer. Finally, the wafer is etched, which removes the exposed material, creating the desired three-dimensional structures. Think of it like using a cookie cutter to create shapes in dough. The mask acts as the cookie cutter, the photoresist is the dough, and the etching process is like baking the cookies. Now that we have our tiny structures, it's time to assemble them into a functioning device.